Welcome back. This time, let's put on our security researcher hats because I have been staring at this code and I keep finding new ways it could have gone wrong. So buckle up because we're about to explore how a simple coding mistake could have given foreign intelligence services a front row seat to America's AI revolution. So let's start with the vulnerability that actually has a name and a number, CVE 2024-56159. This one's a doozy. When Astro has source maps enabled, it can accidentally expose your entire server source code to the public. Now, for your typical blog or marketing site, that's embarrassing, like accidentally posting your diary online. But for a federal AI platform, that's handing foreign intelligence services the complete architectural blueprints of American AI infrastructure. Think about what that code would contain, how agencies authenticate, which AI models they're using, internal API structures, maybe even developer comments with passwords or sensitive details. I mean, we're basically talking about giving China's MSS or Russia's SVR a Christmas gift wrapped in a bow. And here's the kicker. This vulnerability was discovered in December 2024, right around the time this project was being developed. Timing is everything, folks. But that's just the beginning. See, this entire project is built on what I like to call the house of cards, the modern JavaScript ecosystem. And if you've ever built a house of cards, you know that one wrong move and the whole thing comes tumbling down. The AI.gov repository shows they're using hundreds of third-party packages. Each one is a potential entry point for attackers. Picture this. You install package A, which depends on package B, which depends on package C from some developer in Belarus who abandoned it 3 years ago and whose GitHub account might now be controlled by, well, who knows? Remember the colors package incident? This tiny, innocent-looking package that millions of developers used suddenly got hijacked and started printing weird messages? Now imagine that happening to a dependency in the system that connects federal agencies to AI providers. Sweet dreams, right? But it gets worse with their turbo repo setup. See, they chose this sophisticated mono-repo management system, which sounds impressive until you realize it's like connecting all the rooms in a building with the same ventilation system. A fire in one room, or in this case, a compromise in one app, can spread everywhere instantly. Now, let's talk about who would actually want to attack this thing. We're not dealing with your average script kiddie trying to deface websites for bragging rights. Countries like China, Russia, and North Korea would have made this platform priority number one. These aren't hackers working from their mom's basement. These are advanced persistent threat groups with billion-dollar budgets, teams of researchers, and access to zero-day exploits that cost more than most people's houses. They probably started planning their attacks the moment news of this project leaked. The centralized nature of AI.gov would have made it incredibly attractive to these groups. Think about it. Instead of having to compromise 50 different agency systems, they could potentially hit one platform and suddenly have access to AI interactions across the entire federal government. It's like the difference between robbing individual houses versus robbing the bank where everyone keeps their money. And then there's the insider threat angle. Government employees would have had access to this platform, and history shows us that insiders can be compromised through blackmail, bribery, or simple ideological motivation. A single malicious insider with admin access to the console dashboard could exfiltrate usage patterns across every federal agency. The API key nightmare. Let's talk about API keys for a minute because this is where things get really scary. To connect to OpenAI, Google, Anthropic, and Amazon Bedrock, you need high-value API keys, basically the digital equivalent of master keys to these AI services. In a rushed development environment like this, remember, they were aiming for a July 4th launch. I can almost guarantee these keys weren't handled properly. They were probably hard-coded in configuration files, stored in plain text environment variables, or shared across multiple environments without proper rotation. And here's the worst part. When that repository was accidentally public, anyone with access could potentially see these keys. Foreign intelligence services could have harvested them and been monitoring federal AI interactions in real time without anyone knowing. Oh, and they had Cohere in their API documentation, despite Cohere not being FedRAMP certified. That's like installing a security system but leaving one window unlocked. It suggests they were just throwing integrations at the wall to see what stuck. Compliance be damned. Let me paint you a picture of how this could have all gone wrong. It's like a cybersecurity thriller, except it's terrifyingly realistic. It's 6 months after launch. AI.gov is humming along, federal agencies are happily using ChatGPT through the platform, everything seems great. Meanwhile, a Chinese APT group has been patient. They compromised a popular NPM package that the platform depends on, nothing obvious, just a small backdoor that activates under specific conditions. Every deployment automatically pulls this malicious code. The backdoor sits dormant until it detects it's running on federal infrastructure, then it starts quietly exfiltrating data. API keys, conversation logs, usage patterns, everything flows back to Beijing. But it gets worse. The attackers use those stolen API keys to monitor ongoing AI conversations in real time. They know which agencies are working on which projects, which AI models are being used for classified work, maybe even the actual content of sensitive discussions with AI systems. And here's the really scary part. This would be incredibly difficult to detect. The malicious traffic would look like legitimate AI API calls. By the time anyone noticed, foreign intelligence services would have months or years of federal AI interaction data. Speaking of detection, let's talk about why this would have been a security team's nightmare. Modern JavaScript applications generate massive amounts of log data. Finding malicious activity in that haystack would be like, well, finding a needle in a haystack, except the haystack is on fire and the needle might not even exist. Attribution would be nearly impossible. How do you tell the difference between a legitimate API call to OpenAI and a malicious one? How do you forensically analyze a compromise when the application is constantly building and rebuilding itself with complex deployment pipelines? And if you did detect a compromise, clean recovery would be a nightmare. The interconnected nature of the platform means you can't just patch one thing. You'd potentially need to rebuild everything from scratch while maintaining continuity of service for the entire federal government. Here's what really keeps me up at night about this whole thing. Most of these vulnerabilities aren't bugs you can just patch away. They're inherent to the architectural choices that were made. JavaScript ecosystems require constant updates to address security issues, but government systems have lengthy change approval processes. It's like trying to fix a race car while it's speeding around the track. The pace of security patches conflicts with the reality of government change control. You can't just tell a federal agency, hey, we need to update 200 dependencies this week because someone found vulnerabilities. That's not how government IT works. But if you don't update them, you're sitting on known security holes. So there you have it. We're not talking about a few security issues here and there. This was shaping up to be a perfect storm of modern web complexity, government security requirements, and a geopolitical threat landscape that would have made this platform incredibly difficult to secure. The really scary part? Most of these problems were baked into the fundamental technology choices that were made. Once you decide to build a federal AI platform using cutting-edge JavaScript frameworks and a complex dependency chain, you've already created most of these vulnerabilities. It's like choosing to build a house on an earthquake fault line and then being surprised when it shakes. Next up, we'll explore what might happen when this project actually releases, what can we expect to be different, and how will this affect jobs. Until then, stay curious.